I'm going to attempt to solder that tiny resistor. Maybe over. It may be over already. Elektron analog heat. This is a kind of effects processor or sound processor that overdrives and compresses and kind of saturates audio. This seems to be the Simon & Garfunkel signature edition, because the only sound it makes is the sound of silence. It powers on, all the logic seems to work in it perfectly fine, all the encoders, all the pots, all the knobs, all read on the display fine, and I've done a factory reset on it, and it's all logically working fine. There's absolutely not a jot of sound, nothing at all. If I put headphones or line out into it with test tones playing in, you get nothing, not even a pop when you turn on the power switch. I've bought this in this condition. I have considerably less than it would have been retail, of course, and we're going to have a look at this and see if we can suss out what the problem is. I have a suspicion that it's a power supply issue, because, as I say, there's absolutely nothing out of the audio outputs at all. No pops, no hiss, it's completely silent. And if I were to hazard a guess, which is all I can do at this stage, it would be that there is a certain power supply topology going on here, because we've got a single 12 volt 2 amp input, and I'm going to guess that that 12 volt input is divided down by a particular circuit into logic supply and probably positive and negative rails of analog supply, and whatever's doing that positive and negative supply may not be working. That's purely speculation, but in the vein of a couple of other things I've looked at recently, which used things like little charge pump chips to divide voltages up, and that charge pump chip in the last thing I looked at was dead. It makes me wonder if, with absolutely no audio whatsoever, we have no analog power. I'm kind of wary of the knobs on these because they're that kind of the rubbery plastic. If anyone who's spent any time in the 2010s dealing with particularly Newmark gear, especially if you were selling it second hand like I was at the time, it tends to turn to glue, and then it's really, really difficult to clean off. I'm not sure exactly what these are made of. Right now they feel okay, but time will tell if they actually last, or if they turn to a sticky mess. Off with your head. Okay, that's interesting. That looks like a big DC-DC converter already. Coiltronics. One of the first things I noticed when I unboxed it was that one of the parts, it's the wet dry part there, has taken a knock and it's slightly damaged, but it does work because on the display it reads perfectly fine. So my first suspicion was actually that when I took it out of the box, but no, it does work fine. Something I'm noticing here is that there's been a trace cut there, and some work done here has got a chip out of it. Corner of that leg. Well, luckily I can see there are test points there, because we have +5, -5, sorry, -5, +5, -12 and +12. But it looks like there's definitely been something done there. This has definitely had, and something here. What's going on here? Actually, look further up. What on earth is going on here? This has had some bodging done on it. Look at this little LT chip here. What on earth is going on there? I hope you can see that as well as I can. That's a mess. Someone's been in this. Now I've disconnected the screen in the top panel for this point, but I'm just going to power this up and just see on some of the test points what we get for voltages, if much of anything. Of course, as we've seen, the logic side is working fine. Nothing. 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 Okay, so there's our input. That would probably be the logic supply, 4.9. A 0.9 volt, which is probably a reference. Also, this surface mount cap is loose on one side. It's not even attached. What? Just going to desolder one side of this. There we go. That's really difficult because the trace there is huge. Even though I use my finest tip there, I probably need the heavier tip to get in there. Okay, so I've done a little bit of research into this, looked at a couple of data sheets. This Coiltronics unit here is actually just a set of 3 transformers basically. It's just the coils for a DC to DC converter. The little linear technology chip there that's hanging on for dear life is actually the driver. So all of this constitutes a DC to DC converter, and that's what I had sort of suspicions that it may be using, either charge pump circuits or DC to DC conversion. In the meantime, I've resoldered this big capacitor at the top here that was only soldered on one side. It hadn't been soldered previously, but it just wasn't joined. It looked as if someone had tried to remove it or rejoin it, and that's now sorted. And I'm definitely measuring input voltages, no problem, up at the top, but I think I'm going to have a close inspection around this. There's a tiny capacitor missing, and a really tiny one on the board. When I look really carefully, it's stuck to the side of this chip. So this is a real mess, and I'm also not sure what's going on at the bottom here. As I said earlier, this has got a chunk out of it, and there's a cut trace here, and this is a bit odd that the cap's completely missing. It makes me wonder, was there ever a cap fitted there in the first place? There is solder on those pads, so I'm not sure. I might have to contact Elektron about that and find out if I can get any info on this circuit, find out if that was ever used and if it's required and what its value was, because it's only got a component designation but no actual value. The other two at the bottom that look to be the same size are 470s. They definitely look like they're identical profile, so it could have been a 470. But I don't know for sure. I think the next step will be to find a source of this chip, assuming it's not working. It may be working, but it looks terrible, and see what we can do about that tiny capacitor, because that is really tiny, and see where we can go from there. Now, interestingly, there's a jumper there that I've just cleared. It was just buried under a ugly solder blob, but there's actually a little jumper that I guess, by the way it's feeding into a little inductor there, perhaps that's a quick way to disable the DC-DC conversion for the analog side for testing purposes. I'm not sure. Right, quick update, day 2. With the benefit of having some time to have a real good look at this and try and work out what on earth the last repair person was trying to do to it, there's a couple of things I've sussed out and patched up. We've said before, one leg of this capacitor was hanging loose. That's been fixed. One leg, in fact I think both legs of this negative regulator here, LM337, were hanging loose. They've both been soldered back down. The 12 volt, negative 12 volt output here had the trace cut right across it. I've had to repair that with a little bit of wire, solid core wire, just to get that reconnected. The chip that was here, which was the linear technology chip, the LT3575, which controls the switching through the coil. This is not a DC-DC converter module, it's just coils. It's 3 transformers essentially, which you can wire in any combination you want, 3 inductors if you will, that you can feed from a switching control chip, which is what the linear technology chip is, and create your own fairly high current DC to DC converter. So all of this stage is DC to DC conversion, and we've got a couple of LDO regulators that regulate the outputs from the coil on the isolated side, and then there's an LM337 negative regulator here, which I believe regulates the negative 12 volt down to the negative 5 volt output here. So I'll bring in a picture of this chip to show you a closer look of what's been done to this. I noticed that the date code on the chip that was in here was 2019. The date codes on everything else are 2016, so that was a replacement chip. I think what's happened, if you look closer you'll see the center thermal pad is damaged. I've not done that. There's also a massive scratch. I've not done that. That's a clue. I think what's happened is someone has tried to remove the original chip by cutting the legs, and then not realising it had the thermal pad underneath, jammed a screwdriver in the side and tried to lever it out like a crowbar, ripping the thermal pad in the middle. Now, second result of Google for that chip is the data sheet. On the first page of the data sheet it shows you that it's got a thermal pad. It would have been lovely if they would have checked that before they attempted to rag it off the board like that. That's created a difficult situation because I've got to somehow try and get this pad back into a better sort of shape as best as it can be, and then figure out a way to solder that. Ordinarily with these things you heat it up from the bottom and you solder it from the bottom. These got tiny little vias which wick the solder. If you use flux, they wick the solder through from the back, and then it solders down the pad as thermal relief to this big ground plane, without being able to wick it through from the back, possibly. I'm not sure what I'm going to do about that. Despite that, I've ordered a chip. It was 11 quid because it's a discontinued part, but it's worth a go. I managed to get it off quite easily, surprisingly easily, with hot air, and on the actual back of the chip. If I can get that in. Yes, just about. There's no trace of the pad that's been ripped off, so that pad that's been ripped off is on the back of the old chip in a landfill somewhere. But the legs are all mangled on that new chip anyway, and there's a weird little scratch in the top of it which may suggest that it blew up, so they've probably got shorts in it when they fitted it terribly, and yeah, caused more trouble. So I'm going to try and find a way to fit this chip, and possibly fit this really tiny resistor. This wire that's hanging here, this 10k resistor on bodge wire, was just a bodge attempt to try and replace that tiny 10k resistor, that current sense resistor that was missing, just to see if it would wake the chip up. It just ties that pin to ground, so this is just tied to the ground side of this capacitor, the primary ground, not the isolated ground. And it didn't make any difference. Checking it on the scope showed that there's no switching signal happening at all from that chip, so it's not pulling the voltage down to create the switching signal on the primary side. So no go. So the coil has just got DC sitting across it doing nothing, which is why there's no activity on the secondary side. If I can get this chip going and we get some activity and there's enough connection there, and there's enough of a decent connection there to provide thermal relief, then we might be able to get the primary side of the converter working, and hopefully it will wake up the output power supply. So let's wait until the parts come in. Oh yeah, I've ordered a cap for this part as well. I haven't got any of the right voltage rating in my stock, so I've ordered one. This little solder bridge here as well is not factory. I can see scratches around it when I look closely. That's been done again by whoever attempted to fix it. Having said that, that's actually quite useful because it means I can completely disable the power supply to this whole section just by removing that jumper if need be. So let's wait and see what happens when the parts come in and see if we can get somewhere. So here we are a week later. The new chip has arrived and I took the board out just to have a look at the situation for soldering it underneath, and I found more damage. This appears to be the plus 12 volts line, which for some bizarre reason, if we can get the focus on there, was cut twice. This solder blob at the top is one I've just done, but it was cut straight across, and it's also cut across further down. Why it had to be cut twice, absolutely no idea. So I've joined that back up. So I've got a wire on the front and the solder blobs on the back, and this chip, this negative regulator, the LM337, has been an absolute dog to find in this TO252 package because of the component shortage that's going on at the moment. Just so difficult to find. Third time's a charm. I had two sellers, one UK, one Chinese, that refunded me afterwards because they said they'd made a mistake with their inventory and they didn't actually have them. Third one appears to have shipped them, so we'll see if one does turn up. It probably does work, but it's just that I can see now what's happened with this chip out of the corner is that the previous person's tried to lift the legs on it and just fractured the chip. So even if that does work, I don't like the look of it, and if I can get a replacement, and a replacement's definitely going on there. So that big blobby solder join there at the top is kind of temporary anyway. We'll do a better job of that when a new chip arrives. But the LT chip has turned up, and yeah, I took the board out to have a look at the situation on the back, but you'll notice there's a complete lack of an exposed pad to do the soldering from underneath, which is a bit weird. I expected underneath this chip I expected an exposed pad. So I think we're going to have to hot air this, so I'll have to mask it off again, make sure we don't lose that really tiny resistor that we fixed earlier. Then when that's done, I've also got some capacitors. They're slightly smaller than this land here. It may have been in a higher value originally, I don't know, but we're going to try it with a 100, try this new chip and see if we get anywhere. So I'm going to go with solder paste for this job, which I was recommended. I've never tried myself before. Now this syringe is comparatively massive. I've got a nozzle for it. I've been warned that it doesn't like to stick. That's not way too much, I know. I'm going to do it. I don't think I'm aiming to do the pins with this per se, just the pad of the chip. I could do the pins of the chip, but I've just no experience of doing that, so with them being so fine, I'm probably going to find it hard to gauge. Let's get it the right way around. Let's get some shit quick on it. I think we've got it. Now you can see some solder bridges on there. It shouldn't be a problem because they're actually doubling up on quite a few pins to join them to the same track for higher current capacity. All 4 pins on the top side that you can see here all go to the ground plane, and the first 2 on the bottom side connect to one plane, the second 2 connect to one plane. You can probably actually see that pretty well in the camera, more than I can. Obviously I'm zoomed right in here. This was really hard to do. I had to get the really wide tip on the iron in order to just get through the heat sinking of those planes, really, to do it, and just wick a little bit of excess off with some braid, which again was really difficult to do. But I think it's on. I'm going to have a real close look at that with the best magnifying glass I can find, and just see that it's okay. I've powered it on very briefly just to get really quick measurements, because I didn't want to turn it on and leave it on in case there was something wrong, and I'm glad I didn't. We have +5, +12, -12, no problem. -5 is giving out -10. So this regulator that looks all smashed up is definitely smashed up. I've got some of those coming from China, but they're going to be obviously a while. I ordered them about 4 days ago, I think. So they're going to be a while before they come. So I think I'm going to remove this and see where we go from here when that arrives. But at least this chip seems to be running, and we have got voltage, but that's a problem. I've got 5 of these LM337s that were delivered, so I'm just going to do some comparisons between the one that was removed, my replacement that I've just removed, and a brand new one I haven't touched yet. Six megohms on the old one, 6 megohms on the new one. 3.7 megohms on the old one, 3.7 megohms on the new one, so the chip is definitely not faulty. So I'll catch up again, and at this point I want to say a massive thanks to Fredrik and Andreas at Elektron. I've been emailing Elektron, and like many other repairs that I've attempted before, I contacted the manufacturer, raised a tech support question with them in the hope that they might be able to shed some light on what is going off with this regulator situation. Must point out that the LM337 isn't fitted at the moment. I'll explain why in a second. Fredrik and Andreas have been sending me circuit details of some of the power section and explaining what some of these voltages do, which has been an immense amount of help, because so many companies doing modern stuff like this, if you're just an end user and you email them for circuit details, usually they just tell you to piss off, quite frankly. But I was advised that Elektron likely wouldn't be like that, and a friend who advised me there was absolutely correct. They've been wonderful. I asked Elektron if my suspicions were correct, that the plus and minus 12 volts power the analog section, the plus and minus 5 volts power the AKM chips for the conversion for the USB input and output. I was almost correct. The plus 5 and a 3.3, which is a test point for here, power the conversion chips. The minus 5 that we're having problem with powers a control voltage circuit, which is this TLO72 op amp and this tiny Texas Instruments DAC. It's a 16-bit DAC that generates a control voltage signal. That says to me that we've got a problem in this area. There's also a little 3.3 volt reference diode there. So in this area is where the minus 5 volts is used. It goes to the DAC chip along with every other voltage. Every experiment I've tried with the regulation here suggests that if there was a short to ground, the voltage wouldn't go lower, i.e. more negative, it would go higher, i.e. closer to ground. Both of these resistors have just been replaced. That was a nightmare to do because they're so small, and one of them tombstone halfway through it. I've removed the regulator, and I did remove these resistors just to measure voltages and resistances without them. Without the regulator and resistors in place, I get plus 0.35 volts or thereabouts on the 5 volt line. When I put the regulator back in, I get minus 10 volts still, so changing those resistors made no difference, but it was worth trying, it was cheap enough. So I have ordered a TL072 in this TS SOC package, which has cost a lot of money because they're really difficult to find in that package at the minute. I've got a drawer full of the big old dip ones, but that's tiny. I'm going to try replacing that and see what happens, because as I say, the voltages all meet at these chips. So it seems to me that if there's a leak between minus 12 volts and minus 5 volts somewhere, it's likely to happen in either one of these chips. I think the diode, the reference voltage diode, is fine. I'm not convinced it's any of the passive components. I believe there's some on the back of the board as well that connected with the circuit. If I've got to replace that DAC, unfortunately it's about £10 for that chip, but they are available just about. I've got one of the TL072s on the way. So I think we'll, when that arrives, next thing will be to remove this, measure the voltages again without the regulator in place and see if there's any change. If there is a change, put the regulator back on. I don't even have to solder it to test it, I can just press it to the board there. And again, see if there's any change in this voltage, because it seems to be where all the voltages join, or where all the voltages meet in these components. I'm convinced there is something wrong. The op amps arrived and the sun's out. Let's get on with it. Interested to see now if without that chip there's any difference. 0.7. There is a little difference on that minus 5 volt rail. Spot the difference. Yeah, the knob broke off. No laughing at the back. We have a quick fix. Giant screwdriver. I want to see, and this is going to take a heck of a gesture with the hands here, if we have any difference with the regulator on that voltage. Minus 10 still. Damn. Maybe it is the DAC. Do we go for broke and remove the DAC? You can always go back on. Alright, so the op amp's been removed. If I put the regulator on, we've still got minus 10 volts, and there is a slight change without the regulator, but looking at the circuit diagram that I've been sent, the only thing that minus 5 volts is connected to is these three components and then a few passives. So there is a slight change in voltage without the regulator when I test the 5 volt line. Now that I've removed that op amp, I think the next thing I'm going to have to do is remove the DAC. It can go back on if it's okay, but I just need to keep pulling these off and see if there's any change. So let's go for broke. Voltage check again. 0.8 without, so something's changing. -10. Still -10. What is going on? .8 without. I don't hold high hopes for this. 10 volts. Still -10. Alright, you'll have to excuse the mess of the bench. You see this little thing hanging off here? What I've discovered is that through all this messing about fighting with this -5 volt problem, there's a very, very high probability that the LM337s that I was sent are completely fake. I could scream. On this board I've got a TO220 LM337 that I've pulled out of something else that I wasn't using. I built a little strip board there with the same value resistors and tried a 9 volt battery on it backwards. When I put this good LM337 in, I get -5.1 volts. If I put one of the TO252 ones in that I've got, I get something like -8.3 volts. No matter what I did with these, I've gone back and forth on formulas, on calculators, had some help from some people on a technical Discord. I don't think they're LM337s at all. They don't regulate junk. So I've just had to spend the last hour putting all the SMD parts back on that I removed with a new op amp and the DAC that went back on. Some of the tantalum capacitors around there look terrible now. That was mainly from hot air, and one I actually had to remove at the bottom of this chip here just to see if I got a tantalum capacitor short or something. Well, not a short, but I don't know. Found out these are only rated for 6.3 volts, so if they've had -10 volts up them, they're probably compromised. So I've got some replacements, some 16 volt replacements on order. To be fair, that doesn't leave a lot of margin. If it's on a 5 volt power supply and it's only 6.3 limit on a tantalum capacitor, yeah, it's a bit close to the margin. So I've ordered some 16s in the same size. I'm most likely just going to replace all those. So yes, the board looks a mess, it's covered in flux. But when I turn it on, if you can see that on the meter there, oh yeah, and I bought a new meter. What does that voltage say? It doesn't say -10. So this is probably working. I think I'm going to clean it up and try and reconnect the front panel. I don't know if I can do that without putting it in the case, and see if it's actually fully working. I've got a problem now with this. The reason I had to get some chips from China, and we all know that the fake thing is fairly well known. It's the first time it's happened to me. The issue I've got with it is that one supplier in China was the only person I could find that had the LM337s in this TO252 format. I can't find them from anyone else. So either I'm going to have to try my best to track down one of those from someone else and hope it's genuine and just test them on the board first, or find a way to fix the TO220 in there, which is not impossible because the pinouts are the same, the leg spacing's the same if I bend the middle leg backwards, but it'll just be stuck up on a board, kind of held on by the solder. Not super comfortable with the idea, and if it's got heatsink on it like this one I'm using has, might make it a little bit wider, so may have a clearance issue with this capacitor. I've got to have a think about that, but that seems to be the problem all along. My head hurts. Okay, so some time has passed since I last worked on this board, actually about 6 months. I kind of shelved this away for a little while and worked on some other stuff, This was really getting on my nerves. It was really complex. What I ended up doing with that regulator situation is, I think this is a SOT 223 size part that I got from CPC. So instead of trying to get something from China, I ended up getting one of these. I think this was quite expensive. I think this cost me about a £5, something like that. It was crazy to be able to get this 337, but it does fit that pad size on the board, and it works. I've finally got my -5 on the board working correctly. What I ended up doing was, when I put that DAC back on, I scoped around the output because I put this all back together and tested it, and it passed audio, but none of the controls would change anything. And I scoped out this DAC and I realised there's clock and data going in, but there's nothing on the output at all. The output's completely dead. I went back and forth a bit with the guys at Elektron again about 6 months ago, and we reckon that because this has had -10 volts up it, this DAC is dead. It's got a -5 volt limit. I've checked that against the data sheet, and it's dead. So I ordered a replacement, managed to source a replacement, even though it's a obsolete part, made obsolete by the component shortage. It was £8.50 for that little chip, and I just dug this back out today because I thought I'll get on with that. I'll get that DAC chip fitted. I happened to look on the back of the board. Now, if you can see these tiny little, I hope that'll focus, these tiny little resistor packs, they're 4 resistors in an SMD package. They're 47k, which I think are being used for pull up or pull down. There's quite a few of these staggered around the board. I don't know if you notice there, if I can get the light in it just right, there's one missing. It looks like there was originally one there. I don't think it's an unpopulated part, and it looks like one has been broken off. I didn't notice this 6 months ago. So I've got to try and find the size of those and see if I can find a replacement to try and put there, because that could have something to do with it. Oops, just playing the camera. That could have something to do with it. I kind of want to get that done before I have a mess about with this this DAC chip, because it may have something to do with it. I do think that DAC is dead, but if there's where's it gone? If there's a pull up or pull down missing there, it looks like that's what it is, then we're going to have a problem anyway. So as this is a sort of cheap part, as long as I can get the size of it and find a bag of 10 of them on eBay or whatever, I'll try and find a replacement for that, and then do the DAC, and hopefully we might get some life out of this, because as I say, it's passing audio, but none of the controls have any effect, none of the settings have any effect. So I think the DAC that sends the voltages to all the processing chips is not doing anything. So that's where we're up to. Change of heart, I'm going to do the hot air side first, I think. Oh, chips up as well. Parts are off, pads are clear. Get it to land on the board that way, that would be amazing. Because that's the correct way up. some time has passed and I'm back to this project. I actually got this little quad resistor done. It was absolute hell to do it. It's a good job they came in a tape of 100, because it took about 5 just to try and get one to actually stay in place. The solder joints, or the pins I should say, are all bridged on one side, but it doesn't matter because there's a trace that goes down them anyway. They're supposed to be bridged, so that's fine. I'm going to put this all back together and test it. Okay, the board's just got a few screws holding it to the case just for the grounding. I've reconnected the 2 connectors from the top panel. I've connected a signal generator which is doing a 500 Hz tone at line level, and an output just to my little speaker here. Just had a quick check in the manual, remembering how to do the factory reset, which I want to do. So you hold down the active key. Here goes. Well, that's a good sign. And then I can't remember if you press the button, I think, so you press 3. Oh, okay, we've got audio. Let's see if it changes. It does. Do the filters work? The filters work. Bring that frequency down. That's working. That is working. That all seems to be going. Let's just go through. Obviously won't be doing a great deal with just a test tone. What happened there? Oh, maybe ha ha ha. Don't seem to be getting any difference on the resonance. Oh, there we go. Oh, there we go. That is working. Yes. I thought I'd plug in a pocket operator. It's the nearest thing I had that could actually play some music. It seems to work great. All seems to be there. Okay, so we've got an envelope follower. The knobs seem very, I don't know, a bit weird in their action, but that might be a software thing, a settings thing. Don't think that's a fault. seems to work great. This project's kind of been on hold for a long time. It's spent more time on the shelf than it has on the bench. So it's a good 6 months or so since I actually started this video and started this project. And what have I done on this? Okay, all in. I've changed the power switching chip. I've changed the DAC chip. I've changed the little quad resistor pack on the back. A few of the capacitors. Fixed some of the bad bodges and board cuts that the previous tech had done to it. Soldered across a board cut that cut into the layer underneath because it's a multi-layer circuit board. I managed to undo that. Of course, we had all that trouble with the fake negative voltage regulator, which blew the DAC. In fact, I've even still got, that's the old DAC. We've still got the chip. And I still, to this day, couldn't tell you what the original fault that the previous tech went in to fix actually was. I really don't know, and I can't guarantee when it all comes down to the crunch, no pun intended, I can't guarantee that this won't fail again, because I do have concerns about the cuts that were made through the layers of that multi-layer board, that it might suffer shorts. It's not something that I would absolutely depend on, but if I can keep this working and keep it as a studio instrument for the price I paid and even the work I've had to put in on it, I'm more than happy. I'm delighted with the response from the couple of guys at Elektron that helped me out with this. I need to send them an email actually and say, hey, remember me? Well, it works. Here's the video if you're bothered. I'm delighted. I'm really happy with it. I need to button it up properly and test it. Use it, see how it goes. But as far as I can see, everything's running on it. Obviously, I haven't tested the USB, haven't tested the MIDI or anything. They might not be things I'm that bothered about, to be honest. I will come to try them at some point. I'm not going to do anything right now. But the original fault that I bought it with is solved, and it's been a hell of a journey to get there. So thanks for getting through this video if you got all the way through. As I say, I'm delighted that it seems to have fixed it. Certainly everything is on a scale in this, coming back to this, that I have very little experience to no experience of working on. This was pretty much my first experience of working on surface mount stuff that small. I still don't think I'm particularly great at it, but I'm better at it than I started, and yeah, it's working. Thanks for watching.